In this video, we will be discussing first-degree price discrimination and how it compares to uniform pricing. So here we have a problem involving a pawn shop that has recently switched their pricing model from uniform pricing to a model of first-degree price discrimination, where they will charge their customers at their maximum willingness to pay. And we're given the following price and cost function of P equals 46 minus 2Q, and total cost equals 4Q plus 17. And they ask us to find the profit under uniform pricing, the profit under first-degree price discrimination, and to compare the two to see which pricing model is better. So in all situations where they ask us to find the profit, we want to profit maximize to ensure we get the maximum profit we can achieve. So let's start with uniform pricing, and we know we profit maximize in uniform pricing by marginal revenue equals marginal cost. And so we need to find our marginal revenue and our marginal cost from these functions. So if we were to find our marginal cost first, we know the marginal cost is the derivative of the total cost function with respect to Q. And if we take that derivative, we get a marginal cost of 4. Next up, we're looking at the price function of P equals 46 minus 2Q. And we want to find the marginal revenue from that. So first, we need to get to our total revenue, which is found by multiplying the price function by Q. So we'd have Q times 46 minus 2Q. And if we distribute, our total revenue is 46Q minus 2Q squared. And now in order to find the marginal revenue, we take the derivative of the total revenue function with respect to Q. So our marginal revenue ends up being 46 minus 4Q. So now we have our marginal revenue and our marginal cost, so we can follow the profit maximization rule of marginal revenue equals marginal cost, and our marginal revenue was 46 minus 4Q, and that was equal to our marginal cost of 4. And so if we subtract 4 from both sides, and then add 4Q to both sides, we get 42 equals 4Q. And so if we divide both sides by 4, we get a Q, or quantity, of 10.5. So we would try to sell 10.5 units at our pawn shop under uniform pricing. Next, we want to find our price, and we can do that by plugging in our found quantity into our price function. And our price function was P equals 46 minus 2 times quantity, and our quantity was 10.5. And by plugging that into a calculator, we get a price of $25. So we would produce 10.5 units, and we would charge each of those units at $25 each. Now all that's left is to find our profit. So we recall the formula for profit being price times quantity minus total cost. And we know all three of these things, so we can plug in what we know. So we have profit, denoted by pi, equals our price of 25 times our quantity of 10.5, and then minus our total cost function, which was 4 times Q, and Q is 10.5, plus 17. And so, if we plug all that into a calculator, we get a profit of 203.5. So if we were to follow uniform pricing as our pricing model, we would make $203.50. And this is the maximum profit we can achieve under uniform pricing. Now we want to look at the first degree price discrimination model, and it's a different process. So usually a good start is to draw our graph, and we have our price function, which we can denote by P, or our demand function, and we also have our marginal cost, which I'll denote by MC. So we know our marginal cost from earlier, which was 4, and we want to figure out this maximum point. Well, if we look at our price function, which was 46 minus 2Q, we look at our axes, which are price and quantity. And so at this point on this axis, Q equals 0. So what we would do is we would plug 0 into 46 minus 2Q, and so the 2 goes away, so all we're left with is 46. Now all that's left to find is this point right here, which is our quantity. So looking at this, we see that the price function and the marginal cost function intersect. So at this point, this must be where our quantity is. So in order to find our quantity, we would set our price equal to our marginal cost because it's an intersection. So our price was 46 minus 2Q, and that's equal to our marginal cost of 4. And so we subtract 4 from both sides and add 2Q to both sides. And we're left with 42 equals 2Q. And so if we divide both sides by 2, we get a quantity of 21. So we would try to sell 21 items at our pawn shop at each customer's maximum willingness to pay. So we would haggle and negotiate to see where the customer is willing to pay. This way we can get the highest possible price out of each customer. So now if we look back at our graph, we know our Q now is 21, and now we have formed a triangle with our graph. And one thing to recall is the inside, below the demand function, are our surpluses. So consumer surplus and producer surplus. Well, in situations like price discrimination, our consumer surplus is 0. So we can assume this entire area is our producer surplus. And we can find it by using the area of a triangle. So if we were to generalize the formula for producer surplus here, we would have producer surplus equals 1/2 times our P max, or our maximum price, minus our marginal cost, and then times our quantity. And this is the area of a triangle formula. So if we plug in what we know, the 1/2 stays there, and our P max was 46, our marginal cost was 4, and our quantity was 21. And by plugging this all into a calculator, we get a producer surplus of 441. So the producer collects all the surplus in this scenario. So we found our producer surplus, but we still need to find the profit. Now if we recall, the other formula for producer surplus is profit plus fixed cost. And if we manipulate this by subtracting fixed cost from both sides, we have a formula of profit equals producer surplus minus fixed cost. So we have our profit, and that's equal to our producer surplus of 441 that we just found. And then if we were to look back at our total cost function, it was 4Q plus 17. And since 17 does not have any Q's attached to it, we can assume that's our fixed cost because it doesn't change no matter how many units we produce. So our fixed cost is 17. And so our profit is 424. And we can denote this by profit of price discrimination. And we want to compare this to our uniform pricing profit, which was 200.5. And we notice that the price discrimination profit is more than double the profit of the uniform pricing profit. So we can decide that price discrimination is the better pricing model if we can do it. So in certain situations, like with pawn shops or car dealerships, negotiation and finding the customer's maximum willingness to pay helps achieve a higher profit than charging the same price for every single customer. That will conclude this video on first-degree price discrimination.